awareness is one of my big roles of in our study. First, if I will talk about the water demand all over the world, as we see, there's this map was not a new map, but it gave expectation to up to 2025. So, as we see, there is a total water stress in most of the Arab region and Asian region. Drinking water is considered to be a precious resource all over the world, especially with the expectation of climate change impact on water resources. Saving water and minimizing abuse of water resources are the target of many countries vulnerable to climate change all over the world. Reduction of water demand through the implementation of social and technical water loss reduction are the most initiatives. Social intervention are focusing on creating awareness to conserve water through promotion material, schools awareness campaign, and various outreach activities. I have several publications about the public awareness of about how to save water and to good manage with water. These are two of the previous publications, and these are the results of public health awareness. We make a group of discussion between the complete campaign in some villages in Egypt. And we try to meet the farmers as well as the housewives and try to change their attitude and practice toward water. But the study was done along 6 months. We make observation and to assess the change in the attitude and the practice of the persons who involved in the study at the middle of the study and at the end of the study, as we here see that there is improvement in some of these messages in the attitude and knowledge, and reduction in the bad messages. The most important is how to preserve water, portable water from infection, and how to reuse this water, and this was improved. The objective of this presentation will focus on different tools used for raising public awareness toward appropriate behavior related to water and sanitation, and good justification to each tool. From that time to until now, we developed several tools to be tested for us and to find the efficient practice to be applied for future studies. Some of these tools are public sessions, as here in public meetings with different population, and present the message through this public meeting. Other personal meeting, just person-to-person discussion, and to find assess the change that will happen after this discussion. Manuals. We print some manuals about the message we want to send in the language of the participants here in Arabic manuals. We do some posters and put it in attractive places to be noticed by the participants. Also, we make practice how to deal with the problem of water and how to use water in minimum amount and by the proper way. And then, after that, we make a score about each tool to find out the success tool to be used in the future. Public sessions, the success rate was 40% in the change in the behavior and the knowledge of the participated population. Personal meetings, success rate was 50% success. Manuals, especially among the farmers, are just 30% success. And the posters lead to 40% success. Practice make over than 90% of success. 90% of success was among those we do a practice with them. We applied this practice among two different groups among students from school children, students. And we teach them how to wash their hands with the minimum amount and to be perfect washing their hands. After just 2 weeks or 1 month, we found that the knowledge we taught this group of children will reach almost all the school. So they take the knowledge and spread it to the their colleagues in the school, and this makes the knowledge to be more spread, and they do practical well. Also, we do the same among the farmers, the housewives in one rural area, and then after 6 months, we follow this, and we found that houses we do practical tests in it are success to complete with this practice forever. So we can conclude that tools of health education need further improvement, as until now there is no 100% success in changing the behavior. Using manuals for transmitting the knowledge is only success in 30% of the population. Person-to-person interview is better than community decisions in success rate, especially in changing personal behavior. Practice for proper behavior, especially among school children, have success rate over 90%. Before I finish my presentation, I want to give an announce about my environmental research division. These my professors and colleagues and my students in a picture of some of or most of the members in the division. And these are the pictures of the heads of my division that I was belonged to them, and I was trained through their and take experience from their experience. And thank you for every knowledge I took from them. Yes, so I just mentioned here that the departments of the division. My division consists of 3 departments: Air Pollution Research Department. Okay, thank you. Thank you.
We have time for 1 or 2 questions. Please speak your name and
I just would like to ask you how you can measure the rate of successful for different practices that you did.
We make a score, we make a scoring about the change in each message I give to the participant. I make a score about how the change will be success. And after a while, after I make it as multiple phases, each visit I write the score whether there is a change in this score or not. And then lastly, when I complete my study, I define the success rate by defining the scoring of each equation I have and each observation that it depends on question and also observation of the attitude to notice the change in the attitude. When I found the score, when I calculate this equation, I found the final score and then comparing the different tools with each other.
Okay, go ahead. Please state your name.
Sihabi Ahmed Ahmed, IRCC Sudan, Chemical Industry Research Institute. I have the same question like her, but I think you need a statistical evaluation for the success.
Yes, I do it by statistical analysis.
You
Yes.
will take it.
Yeah.
Okay.
You know what she takes? That she did really good.
Okay. And I would like to ask about the population you study. Is it large or small population, or to cover all the consumers?
This study was done not in one study, it's multiple studies. So each method was compared before and after in the situation within the study. But and then these presentations are collectively of the previous study to be compared which success rate was the high success rate from all the previous studies. I answer you? Okay, thank you.
Thank you so much. Can everybody hear me without a microphone? Yes, I prefer. Well, I prefer to have my hands free. Right. Okay. I thought that I'm enough presented now. Okay. So I wanted to make sure that everybody hears me, because I hate this piece of microphone. I'm very happy for being here today and for being given a chance to talk to all of you. And I wish at the end of my presentation that we would have an interactive discussion together about the future of controlling waterborne infection. So it's a bit hard for me. You know that it is a miscellaneous session where everybody is free to talk about whatever. I've been informed about the whole workshop probably a couple of days ago, and I had to prepare something to entertain you. So this is one thing. But the other thing that I was not planning to be well dressed like this. You know, I was not planning to do that, but my wife insisted to have a new suit, and she bought me one. And I'm happy that she's around. Yeah, so that of the workshop. Yeah, but this is because my wife wanted me to be like that. Yeah, I thank her for that. Yeah, so this is not, I'm not well dressed like this every day. So now the issue is, what I'm going to talk about today, you've been hearing a lot about water and recycling water and how to treat water to avoid contaminants or pollutants. But we have to think of other things, that human is in direct contact of water. Within the water, there might be a lot of infections. And you have to think that if you sort of stress treat the water with chemicals or physical, whatever, you might induce changes in these pathogens. And the changes of these pathogens might be, the consequence of this might be genetic mutations. And the genetic mutations might be that the result of this might be that the pathogens would be more tough. And sometimes be resistant or untreatable. So we have to think about how can we manage this and how can we make good surveillance for that. And I'm giving here a couple of examples for waterborne diseases, ranging from nematode, trematode-borne diseases, but also unlimited to this, but rather than vector-borne diseases. And when you talk about vector-borne diseases, you have mosquito-borne diseases. Mosquito-borne diseases can be, for example, malaria. Everybody of you knows malaria, but filaria also would be a mosquito-borne disease. And we hear about arboviruses. So arboviruses would be also mosquito-borne diseases that globally affect the world. So the issue is, if you stress the larvae of the mosquito that are breeding within water, you would expect that these larvae also might have differential vectorial capacity. Their capacity to spread diseases around the world might increase. So we have to think about how can we measure this and how can we understand the behavior of the pathogens. And well, my presentation today is not talking about results, but rather than giving future strategies. How can we do that? So I've talked a lot about what happens due to changes in control or water filtration or treatment strategies. But I wanted to come to a conclusion that active genome-wide surveillance activities at both vector, pathogen, and host levels are needed to quantify the impact of changes that might occur either in the pathogens or in the vectors. And what would be the impact of this on the treatment or the outcome of infection? And for that, I wanted to remind you that we are in this room here are not genetically equal. We have to think that human beings are not the same. So if you look at this photo here, can you see everybody on the photo? Yeah, so now I give you a bit of difficulty. Can you see this? Can you figure out the differences between those guys? No, so let's talk about that. Yeah? So we are in the same country or in the same room or in the same world that are as similar. We're not similar. So we should not expect that the outcome of infection due to exposure of a pathogen or the outcome of therapy due to treatment against any infection will be equal. So we have to think about the genetic diversity of pathogens, waterborne pathogen, but also of humans if they get infected, whether they will develop the same symptoms or whether they will be equally treatable. Yeah, this is something that one of the messages that I wanted to deliver out of it. And for this, Leonardo da Vinci actually, Leonardo da Vinci, he is sort of described this, that even one human at different positions behave different. And we have to think that our status at the time makes our predisposition to infection or to treatment different. So this is also to complicate life. So I do have a recommendation here, because at the end of the session we need to have a recommendation. So my recommendation is, well, Dr. Junaid Zaidi yesterday, the executive director of the ComSats, recommended or asked people to think of centers of excellences that can serve all countries in the ComSats. And I have here a suggestion that we need to establish a ComSats affiliated center of excellence for genomic research to enable active surveillance of mutations occurring in waterborne pathogens as well as their potential vectors and specific hosts. And if you wanted to come up with a conclusion at the end of the session. This is my suggested conclusion. And this center can be placed in my building. I'm offering this. I discussed this issue with His Excellency, the President of the National Research Center today. And I told him that I'm going to offer my colleagues this. And I hope that you agree. And he agreed immediately. So if we think of establishing this genomics center, I'd be very happy to host it in the Central Laboratory Network of the National Research Center. Now let's get to the evolution of genomics. So perhaps you missed this. So what the technology that I'm suggesting to monitor changes that occur in pathogens is developing since perhaps 30 years. And I was happy to survive the whole 30 years and to survive the development in genomics and transcriptomics. So now, everybody of you, maybe the biologists, heard about manual sequencing, where you submit a piece of gene to get the nucleotide sequence of that. And for that, you needed radioactive material to label your genetic material, and you needed complicated autoradiography to have a read. And then you needed to have a short and long run to sort of have the read of the piece of gene that you wanted to do. And usually this took like 3-4 days. So now, perhaps 5 or 10 years afterward, automated sequencing was developed. And with this, you could monitor genetic diversity in pathogens. In order, I don't want to lose you. We are talking about applying these technologies to monitor genetic diversity within pathogens that are waterborne. So with automated sequencing, we avoided using radioisotopes, but we were labeling the piece of genes or the probes that we were using to sequence with fluorescence material. And then we could have longer reads. Afterward, the gene bank developed based on the manual sequencing and automated sequencing, and we could align any of the piece of genes of the pathogens that we are interested in to identify based on reference sequence. But now, when we think about that, the mistakes that were introduced by manual sequencing and then by automated sequencing made life difficult. Whether you're thinking of real mutations that are causing real change in pathogenesis, or introduce mutations due to human mistakes. Because hand-to-hand variations, human-to-human variations would make differences here. And actually, you could get some phylogeny. Some people claim that they have unique identification of particular genes that influence the pathogenesis of a pathogen, but nevertheless, this was not the reality, but due to the fact that the mistake of sequencing would introduce this. So now you get to the microarray analysis, where you could print actually a chip with oligos that hybridize to genomes of different pathogens. And there, you could think of detecting as many pathogens as you wish within a water sample. Again, this was a progress. Nevertheless, the number of the slots on the array that you wanted to print to detect pathogens was limited. And as a result of that, people thought, oh, how can we further develop? And people are now talking about next generation sequencing. With the next generation sequencing, you can sequence millions of reads at a time using adapters. And with that, actually, if you have a piece of a water body where you can collect water and concentrate it, you isolate the mixture of nucleic acids, you can do metagenomics and metatranscriptomics to know as many pathogens or as many organisms as existing in the water. And this was really a big progress in the sequencing or genomics analysis or transcriptomics analysis. So now actually if we go to a canal or brackish water body, collect some water, concentrate it, isolate genetic material, we know what is existing in here. And then if you wanted to follow up the changes in this genetic material due to stress factors, due to treatment or global warming or whatever, you can immediately see this. And you can study the effect of this on pathogenesis on animal models. And then you can predict, but we heard about a lot about geographical information system work that is done in different places in the world. And now if we combine this prediction of changes and then prediction in pathogenesis, then we can tell a lot what would happen in 10 years from now if we think about the influence of this on the pathogenesis of waterborne pathogens. So now, I wanted to take you for, this is a bit complicated than you think. It is not they give the nucleic acid, you get result, and then you conclude. For that, actually, the amount of data that you get is really enormous. So you need sort of basic requirements for that. And for that, you need to learn computer programming. You need to work with Linux-based software or material to be able to understand what kind of data that you're having and to analyze that. And you need also to develop some computer skills. Python would be also one of the requirements. You need to work with something so-called RScript and RStudio to know how to analyze your data. You need to import as many packages as possible to help you to analyze your sequences. You need cloud computing system actually to be able to store your data. Otherwise, your toys like the laptop that you're using under Windows would not be able to analyze this. And you need high capacity storage servers. And assume we have here at the NRC, we developed our capacity to do that. Not only at the level of the cloud computing system, but also at the sequencing capacity. So I'm just telling you that. And we can help sort of being a central hub for this genomic analysis here. And you need to be aware which applications you wanted to do if you wanted to analyze genome. So now, the steps of the workflow, I will go very briefly. Demultiplexing, you need to remove the tags from the mixture of the adapters that you wanted to use to analyze as many pathogens as you wish. But you also need to install some pieces of software. I'm giving an example here, the BCL2 FastQ. So the quality control of the reads. You get a read from, you give your nucleic acid to a person, sequence this for me, you get a garbage. How can you make sure that what you have of data is really useful data for analysis and for conclusions? And for that, you need to be able to estimate the quality of the reads. And I'm gonna give you this is something which you wanted to consider as a bad quality because of the length of the reads that you get, of the stretches that you get is short. But this is, you see that the quality, all this is high, so you have the majority of the reads here are unreadable, unlike this. So you need to know how to look at the data. So you need to use something to cut the adapters from the sequences that you get to make sure that what you are looking at, the sequence, is really belonging to the organism. And what you need to do also is to know how to map. And for mapping, you need to have a reference genome. So you need to know which genome you would use to compare your sequences to. And I think you cannot use a reference genome from China to align organisms from Egypt. And for that, there are plenty of introduced problems because of the fact that the people are just comparing everything together and coming up with conclusions that are nonsense. And for this, you need to have a reference genome for your place. And then you know how to compare to conclude from that. And this is if you wanted to go to do the script for that, you don't need to go through those steps. But these are the steps that you do to analyze the data and to get a map out of it. And then for that, for chromosomal, for visualization of the mapping of the reads. So the top sequence would be the reference. And then the other reads would be the reads that you get evolving every day, every year, or after every stress factor you get. And there you can identify the mutations that might lead to pathogenesis. And then you can go at not only at the genome level, but at the protein level to know what are the impact of these mutations on the function of particular proteins that cause infection. And this is, whether the organisms from year to another would cluster together or will be variable. And I wanted to share this with you before ending my presentation. This is the sort of development of the next generation sequencing, what happened. The genome analyzer emerged in 2005 and took sequencing runs from 84 kilobase to 1 gigabase. So this was in 2005. And then in 2014, the rate climbed to 1.8 terabase of data in a single sequencing run. So you see how much sequencing can we do when you compare from 2005 to 2014. The first human genome, so if we think about the consequences of this on humans, so you, yeah, the first human genome published in Science and Nature in 2001 required 15 years to sequence. So sometimes if you wanted to get as much data as we want, it took of them like 15 years. So in contrast, nowadays, in 2014, we could sequence over 45 human genomes in a single day. So now if we wanted to study, for example, public health issues, if you wanted to know the impact of this infection on human, you could sequence up to 45 persons in a day if you have an outbreak of something and you wanted to study this. So I just wanted to consider the costs in 2005 with the introduction of the Illumina genome analyzer. 1.3 human genome could be sequenced annually. Near 10 years later, with the Illumina HiSec, the sequence system, the number climbed to 18,000. So now, somebody asked Professor Abu Laila about the costs. Sometimes expensive stuff are cheap. So if you develop technology and you think that this is expensive, but the amount of information you get out of it makes it cheaper, then you learn a lot about how diseases are spread in endemic or in southern countries, let's say. So I am not going to talk about this equipment because it shows the capacity of each, but I wanted to recommend some publications. I'm not talking about imaginary sciences. All of them came in 2019. Consumption of drinking water containing nitrosamine mixtures, this alters the microbiome. They look at the microbiome in the gut of people who consume that. And this affects the microbiome, and this would affect also the inflammasome of those persons. Likewise, heavy metal exposure causes changes in the metabolic health-associated gut microbiome. And you get some virome data also, impact of sampling design on estimates of microbial communities, diversities, and composition and agricultural soils, gut mucosal virome alterations in ulcerative colitis. So I leave this with, if you are interested, you can read this literature. At the end, I like to thank the National Research Center for giving me the capacity and the opportunity to be around in this place and to share my ideas with you. But I also like to thank the places where I could learn about these technologies and build also my background and the background of my group, University of California, San Francisco, German Academic Exchange Service, and the Alexander von Humboldt Foundation. And I thank you all for your attention and for giving me the time to share this. As many as you wish. I give you the mic. Yes.
Thank you very much for the talk. My name is Tawfiq Ahmed, working as assistant professor at Center for Climate Research and Development, Comsat University, Islamabad. Actually, I want to mention here that we are working on the different projects. Like me, one of the projects that's relevant to your study, that's impacts of climate change and waterborne diseases. Before that, we have worked on the nanomaterials efficacy. We checked the efficacy against the waterborne pathogens. Then another project funded by the Higher Education Commission, that's impact of food grade and the metallic nanoparticles against the larvae of the mosquitoes causing malaria and dengue fever. What we have done in this project, we extracted the DNA from the larvae of the mosquitoes and identified the different species on the molecular basis, and then we checked the efficacy of the different food grade and the metallic nanoparticles. So we have an excellent biosciences department. Dr. Nishan Heather, he is my partner. He is working on the bioinformatics side, and me, I am working on the environmental side. So maybe we can collaborate and work with you. So, so these are the with this background. I thank you for your.
Very happy, and
yeah.
I wanted to add one
maybe
thing.
we can discuss in detail.
Yeah, I wanted to add one thing. Thank you for the suggestion. I wanted to add something. We do not want to be redundant in the capacity. So if you have some capacity at your place, and we have other capacity at the National Research Center,
Yes, we have.
we can say that we would be jointly doing this. So the Center of Excellence should not be allocated in one place, but rather than spread among southern countries. For example, a place in Pakistan, a place at the NRC here, a place in Sudan, and a place in China. I think there is a room for everybody to collaborate. Oh yeah, no, my friend from Abuja. See, I was, yeah, very happy for having her. Yeah, you know, see, no, let me say one thing. I've been teaching in Abuja in last May for 2 weeks. I enjoyed my stay very much, and I was advertising for the ideas about it. I'm coming back, sure. Whenever I get invitation, I'll come back. Yeah. Right. I tell you one thing. I tell right. So that's really good point. So let me tell you about what we are doing and what we have been doing in the past and what we are currently doing. And from there, if you have this question is squeezing me in the wall. You know, she wanted to show. Yeah, you talked to us about technologies and infrastructure, but what are you really doing? Yeah, I take the point. We're doing a lot of things. If you wanted to know my publications, go back at them. I'm not here to advertise my publications. We have been working on human schistosomiasis for a long time. And on human schistosomiasis, we're working at the molecular level and at the immunological level. And it, right. Right. I'm gonna say. Yes. Yeah. Not only an antiviral resistance. Yes. Right. Right.
For that, you can handle only through genetics. Genetics, very good. Everyone will give it, and we need it. We need to apply to solve problems we don't problem.
Yeah, no, I'm just. No, I have to answer the question myself. I take your point.
We're not going to go.
No,
just she mentioned as a recommendation.
Right. That's exactly what I'm saying.
Let us because of time.
Okay. No, but then I would say one thing, that the Central Laboratories Network and the Centers of Excellence are open for every institute and university in Egypt to give the services that we have. So we provide services. We have the infrastructure ready to serve any institute in Egypt. And you're more than welcome to visit us. Yes?
Last one from Jamaica. I can speak.
You cannot.
Thank you very much. I'm Gloria Obi from the National Biotechnology Development Agency of Nigeria. Thank you, Professor Mahmoud, for your presentation. I am pleased with your recommendation, and it is my pleasure, and I wish that we will integrate it into our final recommendation, because biotechnology is very expensive. I doubt if you have the infrastructure to host the COMSAT Center of Excellence. So we have to work together.
But that's what I said to my colleague here. We would harmonize. So we cannot provide a toy for every individual.
Like the next generation sequencer you're talking of, we have in our
The NAFTA, and the company are offering actually. You know that we are offering a workshop for the countries from non-aligned and other developing countries. Candidates will come to receive training in our center. And if Egyptian candidates are interested, they can also apply to get training on all possible advances,
and
including
postdocs.
genomics, material science, nanotechnology, environmental science. So we have also a multidisciplinary workshop. I don't want to make it very long, but I take the point. We will be collaborating south and south. Thank you for your attention.
That's one.
And if you have anything to discuss, I'm available. The
The
chairperson.
last one,
So we continue later.
Yes, sure. Please.
Councilor Kumar.
Okay, the mic.
he doesn't need my anyway.
Please.
Thank you, Dr. Beckett, but I wonder if the climate change will affect on the behavior of waterborne disease or on the spread of waterborne disease.
Both.
No,
Both.
no, you have a proof that
Yes, I can send you some papers.
no, this just case study, you know. You have case study tell that climate change affect
I
on.
can show you the introduced relation.
Tell us please.
Yeah, go
How
ahead.
climate change affect on the behavior of waterborne
Do you
disease?
want me to learn about that?
He's got the point.
I can talk to you later if you wish.
He will send you.
I can talk to you personally. Sorry, you can talk to her as well.
No, that's okay, that's okay. What's bad I said something brand new. You need it, and you need to use it, and the coordination between us, the both sisters, for this conference. This conference has different people, different culture, but still, one thing is very important for us, we got to work together. Without working together, it's a little foolish.
I wanted to provoke you guys for that. I wanted to stimulate this. If you wanted to talk to me, we can talk at any time. And if you are not convinced, this is your issue. I'm sorry for that.
It affects on the spread, but not on the organism
Okay,
itself.
well, this is your opinion. I can send you papers if you wanted to discuss with me any time.
Should be understood.
As scientific people, there's always others.
Yes, I'm willing to discuss this.
You support this with your documentation, he has another documentation, then here she has another. That's good, but the point that your proposal,
The Center of Excellence for Genomics.
very good one,
Yes.
and we don't support it, and we have another, all the other factors should be included. He proposed it. He didn't say everything. He proposed it, and we are willing to have any discussion about that.
Dr. Hamid Awadi wants to say something?
No, the guy that you know. Okay, the last speaker is a good speaker. Huh? Use the one, use the one, use the one.
Okay. The last speaker in this section, Professor Hassan. He is from inorganic chemical industries and mineral resources research division, NRC, Egypt. His topic is groundwater exploration using your physical techniques, successful case studies. Welcome.
Thanks, Mr. Chairman. Can everybody hear me? Good afternoon, everyone. The topic I'm going to talk about I'm fine. Can you hear me?
Make it easy for you and for us.
Good afternoon, everyone. The topic I'm going to talk about this afternoon is about geophysical exploration. It is a technique for exploring subsurface, a bit different from the previous case studies or presentations. The outline of my talk, I'm going to talk about the problem about delineating the depths and extension of groundwater and seawater intrusion using geophysical technique. This technique is called time domain electromagnetic method. I'd like to be for the basics because I know we have a very diverse background here. Then I'm going to go talk about the results of the field work, interpretation, final conclusion, and some recommendations. Any geophysical method requires a source. We put some energy in the subsurface in the ground and try to excite some physical properties which respond to us. Then we use a sensors as a receiver to measure this response from the Earth and try to analyze this data and come with interpretation about what exactly is subsurface, especially for groundwater or seawater intrusion or any subsurface material. In geophysics, we use different tools, different techniques, sometimes called gravity accounts for density of the rocks, sometimes called magnetic for the magnetic stability, how sensitive the rocks to magnetic field, sound waves like seismic waves about also density distribution, and electricity and electromagnetic, which is the focus of my topic today. How can we use electrical and electromagnetic techniques for sensing the subsurface? Actually, I'm looking for any material that conduct the electricity, like conductors, semiconductors. That of course includes mineralization, groundwater, seawater intrusion, saline water, and so on. Actually, the physical property are measured for electrical and electromagnetic techniques is called electrical resistivity, or its inverse, electrical conductivity, whatever, which one of them. This property has a very diverse, very wide spectrum of values for many rock materials. We're going to focus today about the water aquifers mainly, which have very wide range, start from saline water that have high conductivity, to fresh water that have a medium conductivity, up to sea ice and permafrost have a very low conductivity. In terms of application, hydrological application for geophysics, it's about finding and delineating underground water resources, aquifer monitoring and management, water pollution, and finally seawater intrusion. When seawater intrusion, try to see how far the intrusion of the seawater goes inland. That's because of the pumping from the fresh water right here that let the water go inside. And we'll come up with a distribution of resistivity of surface that can help us to characterize the saline water from brackish water and from fresh water, even just before drilling. So you can save a lot of money before drilling. It tells us if there is heavy here, fresh aquifer or saline aquifer on subsurface. This is a saving of money. The case study I'm going to present is actually from Egypt, from Oman, where I used to work before I joined the NRC a few years ago. The situation here, the problem is you notice that there is an increase of salinity of the groundwater at coastal areas. That's due to aggressive abstraction from the wells, and with low natural charge from the rains, and they don't have rivers there, and rapid groundwater depletion. This causes the seawater to intrude inland, to go inside the land. This causes the high salinity of the soil, and this causes damage for the palm trees, because this is one of the main agriculture in Oman, and also cause a potential health hazard and problems for drinking, and it's also affected the corrosion of the metal pipes for oil pipes and gas pipes. It corroded, so have a very serious problem. So it is important to find a fast and reliable technique or tool that can help us to monitor the salinity change in the coastal aquifer in this area. The area I'm going to study, actually before I go on, just to give you an idea about the water resources in Oman in general. Actually, groundwater represents about 83%, which is the main source of water. The other percentage for different surface water and salination and others. And this water, groundwater, mainly goes for agriculture. Actually, 57 to almost 80% goes for agriculture. So agriculture is the main consumption for the water there. And actually, there is a deficit between the available resources, which is 1,267 million cubic meter, and the demand is about 16.5 million cubic meter. Deficit about 378 million cubic meter, according to the authority in Oman. So there is, and more than that, with the salinity of the groundwater at coastal area, causes the problem to get more severe. So I started a case study, an area in Oman. It's called the northern coastal, just right here. This area affected by the seawater intrusion, right here. So this area of my interest, which I studied. So coastal area of Oman, which is magnified right here, have a unique geology. This area is actually a mountain area. This is a very high mountain area called Jabal Akhdar Mountain, and the water goes all the way from the mountains towards the coast. You can see the channels going over there, and this water is lost in the sea. So they decided that we need to make use of this fresh water that's coming from the rains. So they built what's called recharge dams. This white spots here is called recharge dams. So build some dams to stop the water flow, and it causes two functions. The first function is to recharge the aquifer in subsurface. Second job is to stop the water, seawater intrusion, push it back towards the sea or the Gulf of Oman. So I started this recharge dam, it's called the Hold Dam, because the mountain area is just right here, and this is how the water goes. And the one yellow here is the dam itself, to stop the water and recharge the subsurface with the fresh water, and pushes back the intrusion coming from the sea. The geology of the area is mainly about very thick unconsolidated materials, mainly gravels. I can see it right here, boulders and gravels. And this makes it a very good aquifer to store the water. You have high porosity here. And there's also some clay gravel, some lenses for clay gravels and cemented gravels with depth. The thickness of this one from 600 to 300 to 600 thickness. This map here shows the electrical conductivity, which expresses the amount of salt in the water, how conductive or resistive is it. This is based on the well distribution from the area here. If it is EC is about 2,000 EC in microsiemens centimeter, then it's fresh water. It's from 2,000 to 16,000 microsiemens centimeters brackish. If it's 16 to 50 saline, it's more than 50 is brine water. In the study area, it's about 50% of the wells is about 66,000 microsiemens, which is mainly brackish water. This is because of the seawater intrusion. You can also add the dam I'm studying is right here. And this, in blue, it is fresh water, in red, it is saline water. The study area, I did some field work using electromagnetic method. The surface is mainly, as you can see, gravel and sand, very hard rocks. So not many geophysical techniques could be used except the electromagnetic, which use just wires. We just have a wire here, and the sensor is in the middle here. It's called central loop configuration, just like that one, transmitter, and this is the receiver. Current induced in the subsurface, causing a current flow in the subsurface. And then we measure the earth response. Whenever we have a conductor, we have a response in the surface. I used more than one loop. The larger the loop you are using, this square I mean, can go quite deep. So 20 by 20 reach about 100 meter depth. 300 by 100 can use quite deep, like 500 meter depth. Time domain again just works by if you switch out, we have a current, the step function here, switch out the current, then we induce current to subsurface. And we measure the voltage in the receiver sensor on the top. And then current keeps going down and then go deeper and deeper, and then we have a spectrum at the voltage with time. This data is then inverted, and but to be, instead of time, voltage to be resistivity and depth, because the resistivity expresses the AC conductivity. Then interpreted in terms of geology about different types of layers, depending on the geology, what's in the near surface and deeper subsurface. This is for just one station, one measurement. If you do a cross section at different stations, you get a two-dimensional plot here showing the distribution of resistivity both with distance and depth. Then you can determine where are the high conductivity or low conductivity, where is the saline water, where is the fresh water based on that. This is just a background. This is exactly what we are doing every day. Basically, if you go to airport or a hotel, basically you have to go through this gate. So this gate basically do the same stuff. If you have a transmitter having current, this current will generate a magnetic field. If you have keys or any metallic stuff in your suitcase or in your pocket, this will generate smaller current here. This current generates again a magnetic field. This magnetic field will induce a current in the receiver one. If you have a current flow here, then you have a light or a paper that tells that there's something metallic here. If you don't have anything metallic here, this current will not be generated, so you will not have a beacon or light. This is exactly what we are doing in the subsurface. Consider this man or this suitcase is a target we are looking for. We're just trying to induce current in the ground, exciting some current in the subsurface, and then measure it. This is exactly what we did in electromagnetic techniques or geophysical techniques. This is just a simple, just to follow up what's going on for non-geophysicists. The case study I'm presenting right now, we did like 6 profiles, actually 5 at the dam area, is the dam, right here, and this another one separate profile, 9 kilometers, just for comparison to see an effect. So I did here like 5 profiles using different loops, smaller ones and larger ones. For the first loop, a 20 by 20 small loop, which accounts for a depth about 120, 140 meter depth, the subsurface. You can see the alluvial deposits, that's dry materials like gravels and sand. And you can also see the blue here means high resistivity, the red means low resistivity. So this is a freshwater table right here. And the red ones here just the top of the seawater intrusion lens or tunnel. So this is just the top of it. You cannot see it fully actually because the depth is just about 140, 120 meters. This was compared with EC logs. This is an EC log, electrical conductivity log, and we have a good match at the same depth where you can see the low resistivity zone here at about 100 meter depth. It's well correlated with the EC. EC log was very close in this area at the end of this profile, so we have a good match. This tells us that the measurements here is fine since this is a good ground truth. Try to use larger loop, like instead of 20 and 20, we use 50 by 50. So we can see about 200 meters with depth. So we can have a better definition here for a saltwater intrusion lens, but not complete. But you can also say that near surface stuff are losing resolution. Remember this one? High definition here, high resolution. Here we have a less resolution. So we have trade-off between depth and resolution. So we try to use a larger loop, like 300 by 300. We managed to go about 400 meter depth, quite deep. And we have here much better definition for the lens. It's here intrusion lens, went about 5 kilometers inland. And we lost the resolution for the near surface. It's not very clear at all. But we compare these results with the resistivity log in a while in this area. We have a good match here. A low resistivity with low resistivity from EM. So we have a good correlation between both of them. This tells us that we are in the right track. Another profile is the same. This is closer to the sea. Now, for Gulf here, you can see also a sea intrusion in a shallower depth, about 50 meters, and we're also correct with the AC. Again, good correlation. The larger loop here also again CO2 intrusion along this profile right here. See, you can see that again the good definition for the CO2 intrusion, and this is a diffuse zone. We try to compare all of these measurements with around the dam, the recharge dam. So we try to compare with the far one, that's 9 kilometers, and this one, there's no dams here. So you can see the effect of the dam. You can see this one, this profile, this one, you can see a very severe CO2 intrusion with depth and distance. It's going about 7 kilometers inland, affecting all the crops and the agricultural area and the underground water. And the depth is going from about 100 meters up to 300 meter depth. It's very severe. So the reason for that is that there is nothing to stop the water from intrusion inland. If you compare that with the map I showed earlier, this profile is just right here, where this is red zone here, CO2 intrusion, correspond to that one. And these ones are from the previous profile. So this is a very good correlation between the electromagnetic measurements and the measurements from the well data around the study area right here. To manage to make a three-dimensional plot showing the alluvial deposits, freshwater zones, and saline water zone from an area close from the sea. This is using a 20 by 20 shallow loop, and this is the correlation between the AC log right here, between the saline water and the saline water measurements by the AC log in the neighborhood. So in conclusion, DDM proved to be a very cost-effective tool in arid environment with improved depth of penetration with conventional technical DC resistivity. It's also proved to be quick. The measurement doesn't take much time from the measurement and delineating the position of CO2 intrusion and identifying salinity variation. Part domain EM have a greater ability to locating depth water table. Different loops, I mean, the dimensions of loops, smaller one, larger one, are complementary, so can help you to see the shallow part and deep part if you make a joint inversion. And the DDM revealed the role of recharge dam. So areas that have recharge dam is less affected by this intrusion, while the one that don't have the recharge dams are severely affected. So it's a very cost-effective technique for monitoring the intrusion. So recommendations, if you would like to consult geophysics, could provide a reliable technique for exploring groundwater resources. Also can be used for determining seawater intrusion zone. Time lapse, I mean measurements over time, in a month or a few months. To monitor it, is recommended to monitor the migration of seawater intrusion and level of water table. So it also requires some regulation about amount of pumping from the wells. The authorities should have this role. So it's almost everything. Thanks for your attention. If you have any questions, please raise. The question is about how can we choose the right place or location for disposal of brines or any contaminants in general. If you'd like to dump any contaminants, this includes chemical contaminants, biological contaminants, brines, radioactive even.
Actually, the brine from
Yeah.
that's a big problem.
Yeah.
All the Gulf area.
Exactly, yeah. Yeah. So before dumping it anywhere, we need to make a geophysical survey to see hard rocks. Hard rocks means non-porous rocks. If you have to choose a non-porous place where you will dump the brine, you make sure that there is no seepage, there is no leakage out it to affect the soil or the surrounding rocks. So the geophysics would help you determine what are, for example, the granitic rocks that's not fractured or doesn't have any leakage out of it. So once you determine the proper place, then you can dump it safely, because you are sure that there is no way this can contaminate or have a seepage or infiltration from this area. This is one of the techniques could be measured as geophysical techniques, plus the background from the geology of the study area.
He's talking about geophysics. How we can handle the groundwater. Actually, your title is was Oman was quite different.
Yeah.
It
doesn't matter.
A lot of work.
Yeah.
A lot of work now. We use about the groundwater. We use it. Still, the problem is the groundwater is not that interest for us as fishermen. The lot of work that can be done in groundwater. You want to already do desalination.
Yeah.
No, before you go desalination, please specify what kind of groundwater, the amount, and validate it.
Okay.
That's the technique which should be implemented in Egypt, and we'll have the map for groundwater.
Correct.
To be sure we are using the groundwater the right way and not using it as excessive. It's not excess. It's major and very important for us.
Correct.
But we didn't do the work.
Yeah.
Quite clear. We don't do the work in groundwater. In that area, it's quite different because, as you said, the stress for water in this, you take the groundwater and you take seawater, and then the brine we talk about is a big problem. Now, the Gulf area is not salt water, it's water with salt with water.
Yeah.
We are getting now salt with water, and even in Israel.
Yeah.
Desalination will not kind of solve the problem.
Yeah.
And don't have the right salt of water, it's difficult.
Yeah, regarding geophysics, it's the beauty of geophysics is a universal technique. You can use it anywhere because the concept is the same. So regarding groundwater in Egypt, actually what happened that during the last year was accounting mainly on the Nile River. So we don't give much attention to groundwater because this was easy. Nowadays we have a shortage of supply of groundwater from the Nile. So we start to think about what about unconventional groundwater, like deeper groundwater that's not coming from the Nile River. So this is actually there's a map for hydrological map have been done by the Center of Desert Research Center and the Ministry of Water Resources, but unfortunately it's not updated. It's quite an old map. It's not updated. It's also based on map was.
For your presentation, I would like to ask about if we have a scenario for sea level rise for futures till 2100 or till the middle century till 2015. Can we use this technique to predict what the salt intrusions impact in groundwater?
Regarding the seawater rise, this can be sensed by different sensors, not by geophysical sensor, but there is a sensor can be placed in the sea and monitor the elevation of the seawater. But what I can recommend is to monitor the seawater from the subsurface, because usually subsurface is more severe, because it goes below the subsurface and intrude and then affect the soil and destroy all the agriculture stuff. So if we make a time-lapse measurements, which is my last recommendation, put the sensors and measure, for example, after 1 year or 2 years and so on, you can monitor the level of intrusion, whether inland or in terms of the level. This is one technique. That also can be done by wells, but wells requires a huge number of wells to monitor. But geophysics is quick and easy. So you can make a monitoring time-lapse measurement, for example, once every 6 months, once every year, to see how severe. And then after monitoring, you have to come up with regulations about how much water you can pump from the wells, because people can use it without any control. Because the more pumping from the wells, the more intrusion. Because what you do just to evacuate the air from the soil, let the salt water to get replaced. You take the fresh water, make it empty so that salt water fill the space. So it requires some time-lapse measurements, and then you can make a decision based on that. But from the subsurface, from the sea level, this is done by different sensors, not our physical
The
sensor.
last one behind me, I don't see him. But see, now, we got the sensor.
Mohammed Salah, Minister of Medical Production, Science Technology Center of Excellence. Actually, I'm asking about the Oman case. How about the cost of this study? Is the first question. Second question, I want to know how about the rate of salt water inclusion and how it affects the agriculture.
First question about the cost, and then about
The rate of water inclusion. Yeah.
Regarding the cost, it's not expensive compared with drilling. So for terms of drilling, if you just need to buy or to own these sensors, that you can do it. The measurement time is not that much. You can finish survey in a few days. Actually, one day you can finish one profile from what I mentioned. In a few days you can finish the whole stuff. 1 week should be enough to make good measurements in the study area if you have a sensor. And in Egypt it's available right now. There's many research centers on this equipment, so it can be done. It's not a very big deal. So compared with drilling wells, this is much cheaper. In terms of the rate depends on how much you are pumping water. So it depends how much you are taking water depletion from surface and the water will through. Because whenever you have a space, you will go away. So this is why I should recommend you have some regulations, some governmental regulations about how much water you should pump from the underground water aquifer.
actually I'm asking this question before. Water distillation near
The coastal area, sometimes we take the water, the salt water from underground, not from the sea.
exactly what
That's the best thing to do in Europe. But actually, still, how much salt wasn't examination of desalination, he said, you don't put too much brine. Wasn't the case. Now, too much brine. And that's why now, there's a lot of questions about how you get it from the brine.
Yeah.
From the process itself, it's not the fact you don't have it right.
Yeah.
From the beginning, the technique can be changed because the brine is a big problem and
Yeah.
that to face it, especially the level of government.
One last solution, when I was in the US, what they are doing is they are pumping water. Instead of taking water, you're pumping water in the surface. Make a water recharge. Take water from rivers, for example, and pumping down. When you pump it down, you push it back. This is one other solution.
Okay, thank God for everyone. We contribute we called us miscellaneous, but actually it was very good session. And we thank the speakers and the audience. And we are a little bit behind the schedule. And we hope we have a nice day for you, our friends from outside Cairo. And we enjoy having you around. And we hope. Welcome.
جماعه الكورسات السكشن عارفين الرقم ده ولا لا؟ حضرتك عايز اسف على الرقم. هقول لك اساسا حد مثلا عليك تدور الحرس وعلينا اللي يشتغل في الحرس الناس كلها بتشتغل على الكتير اللي جاي ما ساكن مرتبه في لابوراتوري سترين has nothing to do مع اللي بيحصل في الفيلم بس وناس تقول لك ايه هناخد الكومباوند الفلانيه عشان نعمل انتي الهرس هذا الانتي الهرس against the strain وادي هذا الثاني اسوء ايوه الدكتور فرق مش اسوء انا عارف الدكتوره على النتيجه دي احنا عايشين
المفروض الوقت ده خلاص وعشان كده صح زي ده الوقت ولا بعد المفروض يقول لك اصلا دلوقتي
لا انا ممكن
دول الناس
نرجع بس الناس اللي كانوا بيتكلموا على راسم مدرس الصوت اللابوراتوري ولا اللي جاي من الفيلم؟ طب اللي جاي من الفيلم الأدوية ولا اليوم ولا الأسبوع؟
المفروض ان دلوقتي حسب كام ديس ولا دلوقتي الصح اصلا ولازم اصلا هيدرولوجيكال
أنا مستعد أتكلم معاكم أنا بس
هو القطع البحر لازم يعني هيدرولوجيكال موديل عشان يبقى ازاي عشان اللي هو بيسموه شوك
انتوا بس سلموا على الدكتورة وفاء وبعدين بقى اي حد عايز يديفلوب ايدياز وما بيعرفش يتكلم سوا اقول لكم ايه المهم وايه اللي شرفوا طبعا انا الهدف ما هوش كنت عامل محاضره تعليميه قد بقول انا عايز استقلال لا بقول لكم ايه اللي بيجرى وازاي يجرى وازاي نعمل حاجات معاهم مع بعض
حرب 17
لما بهجت رياض رايي حاجات
يعني عندنا مؤتمر وانا شغال فيه ودرس لايف وكده.